teach a lesson today, or our kids are going to be disappointed. They look forward to us every single day. Get up! Come on, girls! Wake up! All right, let's get into math today. Let's do some math.
All right, let's do this. Still waking up.
You better.
All right, you guys, today we are looking at lesson 5-5 with understanding rates and unit rates. Our essential question is, what are rates and unit rates? So we know that a rate is a special type of ratio that compares quantities with unlike units of measure. So we're comparing two things that are both different units of measure. So a unit rate is a rate in which the comparison is to 1 unit. So the unit rate is the rate per 1. So our comparison is going to be the part that we are comparing to every one of that measurement. This would be our numerator. And then every 1 unit is going to be our denominator, because that's the total of what we are comparing it to. So now let's move on to our examples. So let's look at number 1. We have 78 miles on 3 gallons. What we're comparing here is miles to gallons, and we're writing this as a fraction ratio. So miles to gallons, we're going to be writing that as 78 miles to 3 gallons, because that's what we know. What we want to know is the unit rate. So how many miles would it be for 1 gallon? So we set our unit rate equal to 1 gallon on the bottom, because we keep our denominators the same units of measure, and we set it equal to 1. So we're going to figure out, how do we get from 3 to 1 by scaling down, which then we will divide. And whatever we do on the bottom, we will also do on the top. So 3 divided by 3 is 1. That's how we get to 1 gallon. So let's now divide by the same thing, the same value on the top. 78 divided by 3 is 26 miles. It's very important that your units of measure stay the same straight across. So for every 1 gallon, you can drive 26 miles. Let's move on to example number 2. We have 18 laps in 6 minutes. So we're comparing laps to minutes. So let's compare 18 laps to 6 minutes and figure out, how many laps could we run in just 1 minute? Because this is our unit rate. So we would solve and scale down to get from 6 to 1. And what we do on the bottom, we have to do on the top. So when we scale down, let's divide. 6 divided by 6 is 1 minute. And on the top, 18 divided by 6 is 3. So for every 1 minute, we run 3 laps.
Good afternoon, y'all. This is lesson 5-5. Aren't you ready for your learning intention? What's the point of us learning today? Well, I'm going to tell you. I will be able to understand rates and unit rates. What is our essential question? What should you be able to answer by the end of today? What are rates and unit rates? And how do you know you're successful? You can, 1, use rates to describe ratios with different units. 2, use rates to solve problems. And 3, use unit rates to solve problems. Now let's take out those notes and learn all the things.
Yeah, I'm giving myself like an angle, how like all of our students do, you know? Like just our eyes. All right, here we go. What are rates and unit rates? So remember that our academic vocabulary is on the left. You should already have these in your notes for rate and unit rate. So now let's jump into example number 1 for finding equivalent rates. Okay, this is what we're going to be focusing on. Just find rates or two ratios that are equal to each other. Okay, if we simplify. If the car continues to travel at the same rate around the lap, how long will it take to travel 25 kilometers? So we're trying to see the time it takes to travel a distance. So we're comparing distance to time. Distance is our numerator, time is our denominator. According to our table, we do know that it takes 10 kilometers for every 3 minutes around the track. We travel 10 kilometers. They want us to find how long does it take for 25 kilometers. So let's set that unknown variable of time equal to x, because that is what we're trying to find. Let's use the strategy of cross multiplication to find our unknown value. So we're going to multiply diagonally from each other 25 times 3, which is 75. And then we're going to multiply 10 times x, which is 10x. Because we're trying to isolate our variable, we're going to divide 10 on both sides. Our 10s on the left side cancel out, and we get x is equal to 7.5 when we divide 75 by 10. So let's go over to our table and fill in that value. At 25 kilometers, it takes 7.5 minutes. So at this time, go ahead and take the next minute and a half to find the distance, to find the time for when you travel 5 kilometers, 15 kilometers, and 20 kilometers. All right, so let's go to example number 2 and compare quantities in 2 ways. So here we have the Harvest Market who's selling a crate full of Fuji apples for $12. They want to know 2 different rates that we could represent with this situation. So we have 2 different situations. Let's look at our first one on the left. They want us to find the unit rate in pounds per dollar. So our 2 units of measure that we're comparing is pounds to dollars. And then we have the unit rate, which is per 1. So they want to know how many apples can we buy for $1? So let's set up what we do know. We know that for $12, we could buy 15 pounds of apples. So our 15 pounds would be placed in our numerator, and our $12 would be placed in our denominator. So since both of these rates are set up to each other, we want to find our pounds for $1. We divide 12 by 12 to get to 1. Whatever we do on the bottom, we have to do on the top. So we're dividing by 12 on the top. And 15 divided by 12 is 1.25. So with $1, we could buy 1.25 pounds of apples. So we have 1.25 pounds per every $1. So let's look at our second situation. They want us to find the unit rate in dollars per pound. This time we're comparing dollars to every 1 pound. Our dollars this time would go in our numerator and our pounds would go in our denominator. So now let's put $12 on the top and 15 pounds on the bottom. And we want to know for 1 pound, how much would it cost? So on the bottom, we have to divide 15 by 15 to get from 15 pounds to 1 pound. We do the same thing on the bottom that we do on the top. So we take 12 and divide it by 15. When we take 12 and divide it by 15, we get 80 cents. So for every 1 pound, it would be 80 cents. Or you could write this as 0.8. All right, you guys, so example number 3. We're going to use unit rates now to solve some problems. So they want to know, how far could this family travel in 8 hours if they maintain the same rate of speed? So a family bicycles 25 miles in 5 hours. So we're comparing our 2 units of measure, miles to hours. We get that from the visual on the left. In step 1, we're going to find the unit rate in miles per hour using 25 miles in 5 hours. So let's put 25 miles on the top, and 5 hours is going to be on the bottom. Because we're finding unit rate, we need to find it for just 1 hour. So let's see, how do we get from 5 to 1? Well, we divide 5 by 5. So we take that and do the same thing on the top. Let's divide 25 miles by 5, and we get 5 miles. So for every 5 miles, it takes us 1 hour to bike. So in step 2, it says use the unit rate to find how far the family could travel in 8 hours. Using the same comparison, let's see if you could do this on your own. We have miles to hours. Let's take our unit rate of 5 miles per 1 hour and set that equal to 8 hours. So what we're trying to find here is how many miles can we bike? Go ahead and try this on your own. All right, you guys, so now that you've done this on your own, let's do it together. We're going to take that unit rate, which is super important to find. We could take a unit rate and find anything that we want when it comes to traveling in any amount of hours. Here they're asking us for 8 hours specifically. So how do we get from 1 to 8? We have to scale up. And how do we scale up? We multiply. We're going to multiply 1 by 8 to get our 8 hours. And whatever we do on the bottom, we also have to do on the top. So let's take 5 miles and now multiply it by 8. When we multiply 5 by 8, we get 40 miles. So we just took our unit rate to find a different amount of time and miles traveled. So in 8 hours, the family will travel 40 miles.
Beautiful.
Okay, go ahead and take a couple minutes and answer that essential question by writing your summary. Our essential question is, what are rates and unit rates? So rates are, and then also tell us what unit rates are. And another way that you could do this is by even just providing 2 different examples of a rate or a unit rate. Okay, go ahead and check your answers for the output page. And then go ahead and check your answers for quadrants 3 and 4 on your output page. Okay.